we end our discussion of fluids talking a bit more about turbulence. Now, we've talked about laminar flows earlier, and laminar flows, again, are smooth flows of fluid. But if the flow is restricted in some fashion, if the tube is very small, the viscosity of the fluid is very large, or very small, my apologies, the viscosity is very small, if the velocity is very high, what can end up happening is you end up going from a laminar flow to a turbulent flow. So think of whitewater rapids, right? You have a river that, when it's nice and wide, is flowing in a laminar fashion, maybe not toward the edges, but in the center, a very smooth flow. Again, kayakers equally spaced would all kind of go down the river together. If you've been tubing, you set up your friends in a tube, you all kind of stay in the same location with respect to one another, mostly, as you tube down the river. And then you get to a turbulent section, a rapids, where the water flow is very chaotic. You can sit and spin around, get caught in an eddy or swirl around. Those types of vortices, those types of turbulent motions can occur in the flow of fluid. Well, how do you know if a fluid is going to be turbulent or laminar, right? When you're designing these oil pipelines, you want to make sure that the oil flowing through the tube is laminar, not that, because it's much harder to force turbulent fluid through a tube than it is to have a smooth laminar flow. Another issue is aircraft wings, right? You want a smooth flow of air over the top of the wing. If that flow becomes turbulent, then you can have some serious issues for losing the lift under a wing. So to measure the turbulence, we're going to introduce a concept called the Reynolds number. And the Reynolds number is an equation that, when you calculate the value, gives you an idea if a flow is going to be turbulent, if it's going to be unstable, meaning bouncing back and forth between laminar and turbulent, or if it's going to be laminar. The Reynolds number is 2 times the fluid density, times the speed of the fluid, times the tube radius, divided by the viscosity of the fluid. How, again, viscous is the fluid. If you calculate the Reynolds number for a fluid flowing through a pipe of radius r, and it's less than 2,000, you're going to have a laminar flow. The flow is going to be smooth. Between 2,000 and 3,000 Reynolds number, it's going to be unstable. It's going to bounce between turbulent and laminar. You might get turbulent flow for a while, and then it becomes laminar, then becomes turbulent again. And then a Reynolds number over 3,000, it's a turbulent flow. So in designing, again, these oil pipelines, or water main pipelines, you're pumping water long distances, you want to make sure that your Reynolds number is low enough that you can smoothly pump fluid from one place to another and not worry about turbulent flow. And again, this density is assuming an incompressible fluid.